All right, so let's go ahead and do page 2 now. We'll do a second recording. That way I'll be able to get things up easier for you. Now, formula is 1/2 times a side times another side times the sine of the angle between those two sides. That's your area formula. Plug it into your calculator. 0.5 times 4 times 10 sine 56. And the area is 16.6. And area we always label centimeters squared, feet squared, inches squared, whatever it is. You put a squared on it. Easy peasy? Yep. So, triangle DEF. Don't know if it's a right triangle, doesn't matter. Just write a triangle DEF. Little f is 14. D is 69 degrees. And little e is 8. So if you label it appropriately, you see you have the two sides and the angle between. So you're going to do 1/2 times one side times the other side times the sine of the angle between. For the area formula, yes. So 1/2, I'm using 0.5 in my calculator, times 14 times 8 times the sine of 69. And that gets me 52.28, which rounds off to 52.3. And how am I going to label this answer? Miles squared, or square miles. Those were 4 points each. If you know the formula, they're really easy. If you don't know the formula, good luck. Okay, questions there? All right. In triangle ABC, angle C is a right angle. So this one, it does matter how I label it. C has to be the right angle, then A and B, it doesn't matter which one you make which. It says angle C is a right angle, that's how I know. Find the exact value of the trig function. Find the sine of A, and sine is opposite over hypotenuse, right? If little a is 4, little b is 8 radical 6, and little c is 20. So what's opposite a? If this is a, opposite is 4. Over the hypotenuse, what's hypotenuse? 4 over 20 reduces to 1 over 5. And when it says exact value, that means no decimals. So don't give me 0.2 is what that would be as a decimal, but don't give me a decimal. Okay. Find the exact value of the trig function indicated. So, again, I'm going to draw a right triangle. Find the tangent of theta. Just call any of your angles other than the right angle theta. And we know the sine of theta is 2 over 7. Now, sine is opposite over hypotenuse, right? Yes? So that means the opposite side is 2, the hypotenuse is 7. Clearly, this is not to scale because that side, those two sides almost look the same length. So I'm going to go by that. I need to find tangent, which is opposite over adjacent. So I know it's going to be 2 over something because 2 is opposite. But I need to find adjacent. How can I find adjacent? Pythagorean theorem. 2 squared plus b squared equals 7 squared. So 4 plus b squared equals 49. Move the 4. B squared equals 45. Square root that. And exact value again, so I can't use decimals. So b equals 45. I can draw a tree for. What comes out? 9 and 5, 3 and 3. So since the 3 has a pair, it's going to be 3 radical 5. So my tangent is 2 over 3 radical 5. I have an issue with that though. What's my issue? Can't have a radical in the denominator. So let's do our quick little multiplication. I'm totally running out of room, so I'll put it down here. So 2 over 3 radical 5. Multiply it by rad 5 over rad 5. You could multiply it by 3 rad 5 if you want to. You're just going to have more reducing at the end. On the top, that gives me 2 radical 5. On the bottom, what does that give me? 3 times radical 5 times radical 5 is radical 25. And radical 25 is just plain old 5. So I have 2 radical 5 over 15. That's my tangent. Questions? All right. Draw an angle with the given measure in standard position. Now I'm very particular about all of the elements that need to be included here. Okay, so watch very carefully. Negative 385 degrees. Is that more or less than 1 rotation? More, because it's more than 360. So I know that I'm at least going to be going like this, right? That's 360. How much past 360 would be 385? 25 more degrees, right? So I'm going to draw 25 degrees, something approximately like that. And I'm going to continue my little spiral going there. Now, important part of my spiral, I must have an arrow on the end. If you did not have an arrow on the end, I took off a point because you need to show me what direction you're going. Because direction is important when you're talking about positive and negative angles. Make sense? The other thing you must have, you must tell me either, you don't have to do both, but you must tell me either this angle or this angle. Because every time I give you an angle, I either give you the measure of the entire angle or I give you something within that quadrant to help you figure it out. So this one, because I knew that it was 360 to 385, I'm going to go ahead and label that 25 degrees. So I have my terminal side, I have the little swirly thing in the middle, I have the appropriate arrow, and I have one of these labeled. If I had chosen to label this side, I would label it as 65 degrees because together they need to add to 90. Now again, you don't need to label both of these, just one of them is adequate and it doesn't matter which one as long as it's the correct measure. Yeah?
How many points would you mark down if you didn't do that?
If you didn't do what?
If we didn't do the angles.
Label one of these guys, you would lose one of the 4 points. Yes?
What if you label the arrow at negative 385? Will that count?
No, because that doesn't give me any more information than that does.
Okay.
Doesn't tell me how far into the quadrant it is. Okay. Now, this should go without saying, but since this was in degrees, whatever angle you're labeling needs to be in degrees. Over here we have radians, so whatever angle you're going to label has to be in radians. So, 19 pi over 6. So this is a positive angle, correct? So here's what I did. I went to my unit circle, and we counted by sixths, right? 1/6, 2/6 reduces to 1/3, 3/6, do you remember this? 4/6, 5/6, 6/6. Well, if I go around here, I can see 11/6 right here. That's getting closer to 19/6, right? Isn't that what I'm looking for? 19/6. So this would be 12/6, 13, 14, 15, 16, 17, 18/6, right? Because 18 over 6 would be 3 pi would end up over here. So then 19/6 would just be 1/6 further. So it ends up being equivalent, or coterminal I should say, to 7 pi over 6. Another way I can do it, I can always change this to degrees by multiplying by 180 over pi, graph it in degrees, but anything you label you have to change back to radians. So I know that it ends up being right there, and I go one full time around and then another time all the way there. Again, put the arrow at the end of your swirly and label one of these two parts. Now, if I remember, this was coterminal. So how many degrees, let's talk degrees because we understand that better. How many degrees are between those two? 30 degrees, right? And 30 degrees in radians is pi over 6. So I can either label this as pi over 6, or I can look at the fact that 60 degrees is down here, and 60 degrees is pi over 3. So I can label either the pi over the 6 or the pi over 3, but it must be in the correct location, and it must be in radians. Questions there? 4 points each on those guys. All right, find the exact value of each trig function. Exact value means no decimals. These should be going straight to your unit circle. All right, so if I look at this guy, we have a fourth quadrant angle. Remember our all students take calculus? Remember that? That tells us what's positive. So if I have fourth quadrant, is sine positive? No, it's going to be negative, right? So I know already my answer is going to be negative. Negative 13 pi over 3. Well, if I go to the fourth quadrant, what I want to find is what angle in the fourth quadrant on my unit circle has a denominator of 3, because that's what it's going to be coterminal with. Which one has a denominator of 3 in my fourth quadrant? That guy right there. Does that seem like it could be in the same place? Not quite halfway, a little bit less than halfway. So the sine value would be the y value, and that's negative radical 3 over 2. That's my answer. Okay. All right. 690 degrees. More or less than one rotation, very much more. So 360 plus 360, 2 full rotations would be 720. So if I'm stopping at 690, what is that reference angle there? 30 degrees. So it's 30 degrees before here, which means it's coterminal with this guy, with 330 degrees. So cosine is positive in that quadrant, so my answer is going to be positive. And if I look at that angle that it's coterminal with, the cosine value, or the x value, is radical 3 over 2. So this answer is positive radical 3 over 2. Questions there? Okay, let's go ahead and finish off this section first, and then I'll stop the video and make another one. Negative 210 degrees. So this would be negative 180, right? That would stop there. If this is negative 210, what is this? 30 degrees. So I need to find the angle that's coterminal that's 30 degrees before my 180 degree line. So here's 180. What's 30 degrees before that? 150. So this is the information I'm using to get my answer here. Okay, so tangent, again, all students take calculus. In that quadrant, sine is the only thing that's positive, so my answer is going to be negative. And tangent is sine over cosine. So what's the sine value here? 1/2. Over the cosine value is negative radical 3 over 2. And this one messed with a few people because it does have some simplifying. Remember I showed you to write this one like this? Write the division horizontally as opposed to vertically. Then you can see how you would change it to multiplication and flip it. Your 2's will cancel and you're left with 1 over negative radical 3. Now you just got to get that radical off the bottom. So I'm going to multiply by rad 3 over rad 3, and that gives me radical 3 over 3 with a negative sign. So that's my tangent value there. So far, so good? Secant. What is secant the reciprocal of? Cosine. Remember the s's and the c's go together? So I'm going to find the cosine and then I'm going to flip it. So 21 pi over 4. What I noticed about my pi over 4s is this is 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Do you see how that's counting by odd numbers? So I could go 1, 3, 5, 7, 9, 11, 13, 15. Do you see what I'm doing? 17, 19, 21. So it's coterminal with 225 degrees. So what is the cosine value of 225 degrees? Negative radical 2 over 2. And again, cosine is negative in that quadrant, so that's good. So to find secant, I just flip it. Get that radical off the bottom. That gets me 2 radical 2 over 2 with a negative sign. Those cancel, and I'm left with what? Negative radical 2. Okay. All right. Cotangent of negative 900 degrees. If I think about this, let's see. Negative 900. Well, this is negative 360 is one revolution. Negative 720 is another revolution. If I go another quadrant, I'm at negative 810, right? Another 90 degrees puts me at negative 900. So guess what? We're talking about this angle right here. So this angle, if I look at my unit circle, I have negative 1 comma 0. The negative sign's kind of falling off the page, but we know that's negative 1. And let's see, I know tangent is sine over cosine. Y over x would be 0 over negative 1. What is cotangent then? Negative 1 over 0. So what does that mean my answer is? Undefined, because I can't have a 0 on the bottom. And finally, cosecant of negative 17 pi over 6. I'm going to, let's see, 17 pi over 6. I'm going to count around in my circle by 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17. So we are coterminal with 7 pi over 6 again. Cosecant is the reciprocal of sine. So the sine value there is negative 1/2. So flip that for cosecant, and I get negative 2 over 1, which is just negative 2. Okay? Any questions there? Okay. Let me go ahead and stop this recording.